All right, here we go. Last video, 6.6. This section is all about solving logarithms and exponential equations, which we've pretty much been doing the whole time. So this section is just like a review, again, of everything. And so I'm really going to lay out when solving logarithms the stuff that you should probably look for and try, and the same thing for the exponentials. Again, this is just a quick review of all that, and you're just doing some quick problems, so your homework is not that long. So let's go ahead and get started. So when we solve logarithms, a couple things that you want to try. Use the properties of logs to condense the equation. So if you have addition and subtraction going on between your logarithms, if you have a number in front of your logarithms, remember that that number in front of logarithms can be put up as a power. Addition and subtraction can be condensed down to represent multiplication and division. So try condensing things down to begin with. And then after that, two things are either going to happen. Either you're going to end up with two logs equal to each other on both sides, and if that happens, that means that we can set their x components equal to each other. We'll see that here in a couple minutes. And if you don't have two logs equal to each other, then convert it into exponentials, like what we did the other day in class when we talked about 6.4 and 6.5. So let's do some solving of logarithms. So here, since there's only one log in this is not going to be that one where I was talking about a moment ago, where if you have two logs that are equal, you could set the x parts equal to each other. So in this case, when we look at this, there's no condensing because there's no adding or subtracting. There's not a number in front of your log. So the easiest thing to do for this, convert it back into exponents. Remember in class when we talked about it, this guy right here represents the base. This right here represents the power. And this guy represents the equal part. So what we're looking at is 4 squared equals x. And now you're pretty much ready to give me the answer. So x equals 8. Just like what we've done before. Nothing crazy. Next example. So again, kind of like the last guy. I don't have logs equal to each other. I don't have any condensing that I need to do. In fact, it was already done. That 5x represents addition that was there. So they've already condensed down for us. Really, all I need to do, there's nothing else that I can try other than turning it into exponentials. So the exponential part is 2 to the 4th equal to, the equal part is the 5x. And now you're ready to solve. So the first thing you got to figure out is, well, what is 2 to the 4th? And that ends up being 16 equal to 5x. And then now, get the x by itself by dividing. Divide by 5, divide by 5. X equals 16 over 5. Not 1.6 over 5, that is a 16 over 5. There you go. There's your answer. Again, all this stuff is just like the stuff that we did in 6.3 and 6.4. They're just throwing it at you again. Okay? Another logarithm. Now, this is what I was talking about a couple minutes ago. See how both of these sides have a log base 5, a log base 5. If you have both sides equal to the same log, then all we have to do is take their x components and they must equal each other. They must be the same. So 2x plus 3 must equal 3. And now all you got to do is solve it. So you're going to subtract 3. That gives you 2x equal to 0. Divide by 2, divide by 2. X is 0. See, that's what I was talking about a couple minutes ago. If you have the same logs, then set their x parts equal to each other. See, nothing crazy. Really straightforward. Okay? And then let's do one more log, something like this. So notice in this one you have addition and subtraction between two logs. Let's go ahead and condense this down. So remember that subtraction really means that there's division between these two. So what we have is log of 2x divided by x minus 3 equal to 1. So that's what we really have. So all we have to do now is think about what's going on. Well, do I have two logs equal to each other, like in the last example? No. So what we're going to have to do is turn this into an exponential. Now, many of you are like, well, Mr. Armstrong, where's that base? Remember, when we just have the word log, there really is a base here. It is a base 10 log. So when we convert this, you're looking at 10 to the first equal to 2x over x minus 3. So now you're looking at this. Go ahead and figure out your exponential real quick. So 10 to the first is really just 10. 2x, x minus 3. So this is what you have to solve. Now you're probably thinking, how do I solve this? Again, what number is underneath the 10? It's a 1. All this is cross multiplying. Take 10 times x minus 3. So that'll give you 10x minus 30, because you got to multiply it all the way through, equal to, what's 1 times 2x? 2x. Okay? And now you can solve that. Pretty straightforward. So I'm going to go ahead and bring the 10x over to the 2x. So I'm going to subtract 10x minus 10x. That gives me negative 30 equal to a negative 8x. And last but not least, divide by negative 8. Divide by negative 8. And when you go to your calculator and you reduce this down, you get 15 over 9. Because a negative over a negative becomes a positive, and 30 over 8 can be divided by 2, which reduces down to 15 over 9. So in your assignment, those are the kind of logs that you're going to be dealing with. Those are the kind of logs that you're going to have to solve. And then the last piece, I believe you're going to have 2 questions over solving exponentials. Okay, so let's just talk about solving exponentials real quick. So as you saw in class when we talked about 6.3, 6.4, you could turn them back into logs, but we're going to make it a little bit easier this time. Whenever you want to get an exponential by itself, the easiest thing to do is to ln both sides. Take the natural log of both sides. Because remember, a natural log will cancel out the e that will happen on both sides. Because a natural log and e are the inverse of each other. So it'll just cancel out. And once you've done that, you can... Sorry, let me back up a little bit. I should have just opened all this up. So once you've taken ln of both sides, you could basically solve then. Some other things that you could do, you could use properties of logs to expand the equation out. So once you take ln of both sides, you could use property of logs to expand that equation out to help you solve. From there, also if the bases are equal, then you could set the exponents equal. This last guy right here is the same as what we talked about when we had logs that were equal. Remember when the logs that were equal, the x part is the same? Well, if your bases of your exponents are equal, then that means the exponent component must be the same. So these are all just different things that you can try when dealing with trying to solve exponents. They're really going to be nice and easy, guys. I promise you on that. So 2 things to really try and use is taking ln of both sides to cancel out the e, or if you have same bases on both sides, then you can basically just say, oh, the exponent part must be equal. And we talked about that back if you watched the video for 6.3. So let's do 2 quick examples. So we have 3x to the 14. there's no way I can get the 14 to turn into a base of 3 to some exponent. That's just not going to happen. So what we have to do in this case is we're going to take an ln of both sides. Okay? So what that looks like is I'm going to put ln here, and I'm kind of like sneaking the ln there. So what you're really looking at is ln of 3x equal to ln of 14. Since we couldn't set the exponents equal to each other because we didn't have the same bases, we had to take an ln of both sides. And then from here, we can expand out, because back in 6.5, we talked about what happens with an exponent. We can take that exponent and shift it to the front of this. So what you have is x ln 3 equal to ln of 14. And now you're ready to get the x by itself, because between the x and the ln of 3, that's multiplication. And how do you get rid of multiplication? You divide. And now you know what x is. X equals ln of 14 divided by ln of 3. And there you go. So in this case, we had to take an ln of both sides to solve, do a little expanding, and we were good to go. And I believe that's the last problem that I've got. So good luck in your assignment. It's not that hard. You'll be just fine. And I'll see you in class for 6.8.